The project name is Automatic Name Entity Recognition for Addresses and Dates in Real Estate Legal Archives. So the idea of it is that you will be able to scan handwritten documents or PDFs, and it will be automatically able to understand which ones of them are addresses and dates. So first of all, background, which is pretty much why we're doing this. First, we're trying to tackle an outstanding issue, and it's that we've got unstructured data, which doesn't allow us to query things in normal sense, in the sense that we cannot do SQL queries against it. There's no way of knowing how things will be presented in front of us because it's text. And it's even more problematic since over 80% of the data out there is unstructured data. On the other hand, we have machine learning, which is the method that we're going to apply in this project. Machine learning is a big concept, but we're specifically talking about structured prediction learning, which helps us identifying sequences of words that mean something. In this case, we're trying to identify sequences that mean addresses or dates. How is that done? Is through this process in which we start having a document repository, which through object character recognition, we can transform into text documents. Then we annotate that, we transform it into something that the machine learning algorithms can understand, which are sparse feature vectors. Then we do data partitioning and train the model and then evaluate the model. So prior work. I'm starting not from scratch, but from work that was done by QUT and his team during holidays. So it's approximately a month ago. The only issue that it's got is that there are multiple applications in which each one of them does one part of the process, but they do not communicate to each other. They're just separate applications. So if you want to do something, you'll have to learn to use 5 different applications, learn how to configure them, and then run them in the right way. So the aim and scope of this project is to develop an experimental named entity recognition framework that allows us to compare the results of configuring it in different ways. Meaning that, for instance, if I use machine learning algorithm A, what happens if I use algorithm B? Moreover, what happens if I change the way I'm annotating the data in the documents? So the idea of this is to have a framework that once you set those things up, it will tell you A or B will be better for this or this reason. The main deliverables are going to be a name entity pipeline framework, which is the main product. The evaluation results and analysis of some of the hypotheses they have about the data they have, and that may improve the results they had before. And the documentation of both the framework and how the project management was held. The significance. There are 2 main things here. The first one is that we want to untap the information that is hidden within all of those documents. And the second of all is that we want to give a methodological way of identifying which is the best way to tackle different problems with different configurations. The project methodology. Development-wise, we're going to use agile development strategy because it's iterative, which allows us to have early feedback from the main user because we've got both the supervisor and an industry behind us. We have close business and development stakeholders, which will enable us to go faster. And we'll have weekly updates and review of work done and discussions in order to gain the feedback as early as possible. Research-wise, we're using literature reviews to figure out which are the algorithms that should be implemented in the first stage of the framework. And then we're going to experiment with different configurations and algorithms. The project plan follows more or less what the process is like. So in the first case, in the first iteration, it will add the labels to the existing database, then it will create the OCR module, the annotations module, then the data transformation. So then go to data partition, evaluation, do the experiments, and then report what are the findings that we have. Risk and constraints, the first one of them, and then most important is the time because we're handling 5 different applications that now have to be under the same umbrella, which means a ton of development. Moreover, when you're talking about machine learning, those are algorithms that do not run in a couple of minutes, but it usually takes a whole day of computing to finish one of those. So that's one of the main reasons why we use time-boxed development, because that way we know we're on track or not, and we can do something to solve it on time. The knowledge, because we're not only talking about machine learning, we're talking about recognizing characters, we're talking about software engineering to figure out the best ways of allowing people to modify it. And the only way we can keep up to all of that is having a tight communication between the business stakeholder, the supervisor, and myself, so that we can solve all of the problems as they arise and the fastest way possible. And finally, the main constraint is that all of the development has to be done on open source software, and that the main development languages will be Java or Python, since most of the artificial intelligence libraries are made on top of both of them. And that's my project. Any questions?
Thank you. It's a good presentation.